All right, let's talk about the second type of stress that can stress out a system, and that's pressure. Okay, now think about this. Pressure, we've talked about already, guys, in terms of your factors for increasing the rate of reaction. What substances are only affected by pressure? All right, if you remember it, it should be gases only. So when we're talking about Le Chatelier's, it's the same thing. Only gases will be affected by it. So if you have solids and liquids and stuff, they're not going to be affected. Pressure has no impact on those, okay? Every other state in the reaction is unaffected, and I cannot stress that enough. So as we go through, and again, in some of the practice that I have for you, that's what you want to remember, okay? Now, a little bit different than the last one, okay? If we increase pressure, we go to the side where there's less gaseous moles. So you've got to count up the coefficients. That's going to be the key here with pressure, all right? If you decrease pressure, you go to where there's more moles of gas, okay? So increase, you go to where there's less gases. Decrease, you go to where there's more. So it's kind of an inverse thing here, kind of, if the way kind of I remember it. So find a way that works for you, make sure you know it. But again, it's only for gases. So know if the reaction contains no gas molecules, or if the reaction has the same number of gas molecules on each side, there is no effect, okay, and no shift. So it makes your work really easy if you have that case, all right? So let's jump into some examples here together. So we've got gas on the left and aqueous on the right. So remember that, okay? Remember, hey, I've got only one gas. So this guy is not going to be affected at all by pressure changes. So if we increase the pressure, the concentrations of which species will increase? Well, when we say increase, what happens to our shift? It shifts to the side that there's less gaseous moles. So in this case, the shift that's going to take place is going to shift to the right. What kind of effect is that going to have? Well, take a look, guys. We already crossed out on the right. There's no gases. So there is no effect, okay? None will increase their concentration, okay? So pressure is going to, move to the left side of the gas moles, but that's not going to be changed because there are no gases over there. Number two, if we increase the pressure, the concentrations of which species will decrease. So again, we're still shifting to the right, okay? So, which one's going to decrease? Well, the one that was gas. We shifted to the right, so CO2 is going to change. Number three, if we decrease the pressure, all right, so now decrease, we shift to where there's more gas moles. Well, there's only one gas mole here, guys, so we're going to shift left in this case because we're removing it. So which concentrations of species will increase? It's going to be CO2, and it's gas. I'm sorry, we should have gas for both those because they're both CO2. And the last one, if we decrease the pressure, so we're still shifting left. Concentrations of which species will decrease? None. Okay, because again, it's not affected by the pressure shift. So again, typically, I'll be honest, when you are dealing with Le Chatelier's, guys, they're going to give you, on the reagents, most likely, all gases. So you won't need to worry so much about that. That's kind of a special case, which is why I wanted us to do it together. Let's look at example number 2. This one, I would encourage you guys to try to pause your video and then try to answer these 4 on your own, and then go back and check your answers. All right? So first things first, pressure is what we're talking about here. So look, okay, they're all gases, so that's good to know. Now what I want to do is count up how many moles. So on the left, I have 1 here, right? If nothing's written there, it's 1 plus 3. So I have a total of 4 moles of gas on the left, and I have a total of 2 moles on the right. So that's something just to kind of keep in mind, because we said, if you look back at our notes here, okay, increase, we go to where there's less moles of gas. Decrease, we go to where there's more. So, increase the pressure. So, what's the direction of the equilibrium shift? Increase pressure, we go to where there's less gas moles, so the right has less, so that means we're going to shift to the right. You could again draw an arrow if you want to. Number 2, if we increase the pressure, so again that's that shifting right, so it's going to go to the right, the concentration of which species will initially increase, or increase initially. That's going to be the one that's on the right, which is ammonia gas, and I wrote that wrong. Number 3, if we decrease pressure, okay, so now what's going to happen to the shift? Well, decreasing pressure, we go to where there's more moles of the gas, so we're going to shift to the left, the concentration of which species will decrease initially. So notice again, it says decrease here. That's going to be ammonia again. Decrease pressure, so again, still going to the left. Concentration of which species will increase. Again, that's everything on the left side of the arrow. So that would be N2, and it would be H2. Okay? All right, so that's our second stress, which is pressure. Now let's talk about temperature. And guys, temperature is going to be very similar to concentration. Okay? Temperature's initial stress involves increasing or decreasing the heat component of a reaction. So this is very much like concentration. You know, where we added or removed a substance. Consider heat or energy to be substance. So heat could be symbolized as heat. It could be just called energy. It could be a numerical value that has a kilojoule or joule unit as well. So notice here in this one, all right, here and there is what it looks like in those two reactions, but it could be something else. It could be a numerical value as well. So when heat is increased, the reaction will again shift away. So increasing temperature, it's like you're adding temperature or you're adding heat. That's the way I think about it. From the reaction side containing heat in the endothermic direction. Okay, endothermic, remember, means absorb heat. So you're going away from that where the heat is, where the heat is going to be the exothermic, so it goes in the endothermic direction. When temperature heat is decreased, the reaction will shift toward from the reaction side containing heat. This is in the exothermic direction. So when you're going toward the heat, guys, that's where heat's being produced. That's exothermic. When you're going away from it, that means it's the endothermic, all right, where it's being consumed. All right, so remember, our AA and TT does apply here. Just think of heat or temperature, guys, as a concentration effect, okay, like it's a substance, which it is. So here it is. There's where heat is. If we added heat, okay, that means this is going up. I'm going to go away. So add heat, we go away. That means I'm going to shift away from that. So that my shift is to the left in number 1, which concentrations will decrease. That means everything next to the heat is going to go down. So NO is going to go down. H2O is going to go down as well. Okay? So number 2, separate. So redo the equilibrium. If we add heat, so heat's going up. So it's going to shift to the left again. Which concentrations will increase. So that means everything on the side where my arrow is pointing. So equilibrium arrow is to the left. That means everything to the left of my reaction arrow is going to increase. So that would be ammonia, and it would be oxygen. All right? I would encourage you guys to pause the video, do example 2 on your own, and then come back and check it out. All right, so number 2 is a little bit different. It doesn't say heat or energy, but we have kilojoules. Okay, so right here, that's the component we're going to look at with dealing with temperature. So if I remove heat, that means this guy's going down. I'm going to shift toward it. So take toward, so I'm going to shift toward where I'm taking it away. So my equilibrium shift is to the left, which concentrations will decrease. So that's everything away from where my arrow is pointing, which means those guys, CH4 and O2, are going to decrease. Okay. So number 2 is a whole nother problem. I'm still looking at the kilojoules because it's heat. So if I remove it, okay, it means it's going to go down. I'm shifting toward it. So my equilibrium is going to the left. Which concentrations will increase? CO2 and H2O. Now, I know I kind of went through those last couple examples, guys, a little bit quickly. So if I went too fast, pause the video, go back and rewatch it, call me over, let's have a conversation. There's lots and lots of extra practice, guys. Do the practice. So you have a practice sheet here in the packet, but then you have extra ones over there. Make sure you do a lot of practice with this. Last thing to know is what I have highlighted down here for you. Guys, temperature is the only condition that affects the value of K. Now, K was from our last video or a couple videos ago. Remember, we're only knowing it, guys, just to kind of be aware of how to write a K product. Again, this is more of an AP concept, but I want you guys to know, if you were to see a question like this, temperature is the only condition that will affect the K value. All right, so until next time, go ahead and do practice 6, and then make sure you follow the See the Extra Practice binder for more practice. It has a whole table and chart in there. I'll see you later.